If instead we do know sigma, the population standard deviation, and we are still trying to construct a confidence interval for a population mean, then we'll actually have an easier time of it, because we'll be able to directly use the central limit theorem for the sampling distribution of the sample mean as a random variable. So, in other words, so for subject 2, a random sample that either has n is greater than 30, so its sample size is sufficiently large, or comes from an normal distribution, then we're able to extract the sample mean as a point estimate, and by the central limit theorem, we're able to use the standard normal distribution in this case. So pay attention to the minute differences mathematically, or computationally, I should say, between how we construct this confidence interval versus the one that we covered in the previous video. So our margin of error formula for, or E, is z sub alpha over 2 times sigma over square root of n. So remember, this is the critical value from the standard normal distribution. Sigma is the population standard deviation. And n is the sample size. So actually very similar then to what we found in the previous video. And that means that at the alpha minus, or 1 minus alpha confidence level, we are 1 minus alpha certain or confident that our population mean lies between the sample mean plus the margin of error, which is given by the formula we gave above, and the sample mean minus the margin of error. So again, we have a lower bound on our confidence interval, and we have an upper bound on our confidence interval. And of course, can we rely on a TI-84 to do this for us? Of course we can. So for a TI-84 and all of its variants, we can use Z interval. Also in the tests menu. And what Z interval will construct for you is it will find the margin of error, which means then you will have to put together the confidence interval using x bar minus E and x bar plus E in interval notation. And for the sake of making sure we have a standard, we will keep the precision to 3 decimal places. So 3 places after the decimal point. A note here about what exactly we're doing with margin of error. Now that we've gotten to a far enough point that we can discuss what exactly margin of error is telling us. So first of all, we know that margin of error as a function, right? So margin of error depends on a few different things. So it depends on the standard deviation, of the underlying data set, relies on the sample size, and it relies on the corresponding z-score, right? So, or or t-score. So sampling distribution percentile. Each of these is affecting the margin of error in different ways, right? So larger sample size, we want that to, so larger sample size means tighter E, so smaller E. We want a smaller standard deviation, and we want a larger percentile, typically, because we want to be a certain amount of confidence, right? So it's a balancing game between all of these components of the margin of error, and all of them come directly from the sample and our conditions that we want. So keep in mind then how, if we have the two different cases, we have either the case in which we have to estimate the standard deviation, or the case where we are given that. The main differences then are these two, which are possibly different, most likely different, and these two, which account for different variations, so different standard deviations, and of course the sampling distribution percentile depends on that.